This is video 3.3.1, and the goal here is to use logarithms to expand expressions. These are going to be some key skills to being able to solve logarithms for missing values that we'll be doing in the next section. So understanding these properties will be essential. So the first three properties, we talked about these in class and why they work, but it's really important that you get them memorized. Do not follow normal arithmetic rules. The logarithmic function does not follow normal arithmetic rules. So in taking a look, when we have a product, we can split that up as a sum. Okay, so products become sums. Quotients, or fractions, become differences. So when it's written as a quotient inside of the log, we can write it as a difference. And of course, vice versa. We can go backwards in the same way. And then the power rule. So if we take a number to a power inside of the log, we can drop that power outside and rewrite it in this fashion. Now notice one key thing, that b is always the base for the beginning and the end values. So the base stays constant when we're working with these properties. So you have to have the same base when you're doing these properties. Okay, so let's take a look at some examples with these properties. So the example is asking us to expand the following. So I'm going to take and I'm going to expand it, meaning I'm going to kind of separate things and make it look longer and bigger, hence the word expand. So log base 10, remember log is base 10 if there's no base written. So this is log base 10 of 10x. I can expand that because it's written as a product, 10 times x. I can expand that and write log of 10 plus log of x. Now the good news is I know what log of 10 is. Log of 10 is 1. So this is really 1 plus log of x. I have expanded and even simplified. And that's my first solution, my first example. The next example, now we have natural log. So when working with natural log, the base is e, of course. So now I'm going to, but I notice a division in here, so I'm going to separate it by using subtraction. So I have natural log of e to the third minus natural log of 7. Expanding using the quotient rule. The good news is I can use more for this one and expand further and rewrite it as 3 natural log of e minus natural log of 7. And even more so, I know the natural log of e is 1, because e to the first power equals e. So this is really just 3 minus natural log of 7. And I've expanded and have a final solution. I can even get a decimal value at this point because there's no unknowns in this quantity. So that is the second example. The third example, now I have a power. It's no longer in one of my regular bases. So now I need to work it. It looks like it's going to be a power rule because I have to the fourth power. So now I'm going to take and drop the power 4 out front and rewrite this as 4 log base 7 of 5. And that's all I can do for that one. The final one is natural log, and it's the cubic root of x. Now remember, a cubic root is the same as x to the 1/3, the reciprocal of 3. That's the same power as the cubic root. And since it's a power, I can drop that power out and rewrite my answer in this way. So there's my fourth example. So I need to know that the cubic root is the same as the 1/3 power. Okay, so that's some expanding. Let's take a look at another one where we have some more general expressions. So these are going to take a little bit more time. I notice a product. I also see some powers, but I'm going to first separate the product by writing it as a sum. So log base b of x squared plus log b of the square root of y. Then I'm going to use my power rule and take the 2 out and rewrite it as 2 log b of x And again, I'm going to take this power out, knowing that the square root of y is the same as y to the 1/2. I'm going to take the 1/2 out. 1/2 log base b of y. And I have a simplified, expanded, mind you, an expanded expression. The next one, log base 6 of a quotient. There's also, again, some powers in here and some products. There's a product in the denominator. But let's start by getting rid of the quotient. So I'm going to rewrite this as log base 6 of x to the 1/3. So I'm already trying to think about my next step here. So I'm changing x, cubic root of x to x to the 1/3 minus log base 6 of 36 y to the 4th. So the first expression will be simplified after one more step. Take out the power. So I'm fully expanding. It pretty much means get a very simple term inside of the log. Get everything out if you can. Now this next expression, inside here is a product, and there's a power. So I'm going to start with, first of all, I'm going to put minus for this minus here. And then in parentheses, I'm going to expand log base 6, 36 y to the 4th. I'm going to expand it using the product first. So log 6 of 36 plus log 6 of y to the 4th. So I expanded using the product rule. Continuing here, I'm going to expand, I'm going to keep my front end here because that's as simple as I can get. But now I'm going to subtract each piece. I'm also going to kind of simplify that. So here's a key factor here. You have to be really careful with this minus that occurred up here because this minus, both of these terms that are here have to be subtracted. So I need minus log 6 of 36 minus 4. I'm going to take the 4 out for the exponent, log 6 of y. Now I have expanded, however I can simplify a little, so I always want to do that. So it looks like I'll have 1/3 log base 6 of x. And since 36 is the same as 6 squared, that tells me log base 6 of 36 is 2, because 6 to the second power equals 36. So this is minus 2. That's what that value is. Minus 4 log base 6 of y. And I've expanded and simplified a bit. So that's an equivalent expression to my original. So expanding will help me simplify and clean things up, and it will also help me solve equations on occasion. So be prepared to expand, and that will be what your assignment is on in this section. So key things here. You have got to be careful. You have got to be careful. You cannot use basic arithmetic rules like distributive property. So it is not equal if there is a sum inside. You cannot separate it into the sum of natural log of x plus the sum plus natural log of 3. You cannot separate it that way. In fact, all of these are incorrect. And these are listed in your book. I can tell you what page they're on in case you can't read all of these. If you're prone to common silly errors, make sure you look at page 403 in your book. Page 403 if you cannot read these. But these are not proper simplification of logarithms. Okay? These are proper simplification when we're dealing with regular functions like multiplying, adding, subtracting, and dividing. Many of these would work. However, this is not a regular for your basic 4 operations. These are functions, logarithms. They have very different rules. So please do not make these common mistakes. Okay? And we'll keep reviewing that every day until we make sure that nobody's making those common mistakes. So here are your checkpoints. I'll leave the properties up so you can have them. You should have copied them down. But the properties are here. So expand these as much as possible. Don't forget that if there is no base, you're in base 10. And of course, natural log is in base E. That should help you simplify as well as expand. Okay, leave everything in exact form. Don't put any decimals within here, but definitely expand it as much as possible, just like you saw in the video. So bring your questions into class, and we'll go over them when the video is due.